To do this problem, we should know that power is half rho v omega square s naught square a. So s naught is the amplitude of the particle. A is the area through which the wave is propagating. So in case of a point source, this area will be 4 pi r square. So we can say power is some constant times s naught square r square, because for a medium rho v and omega for a wave and 4 pi everything else is a constant. So power is of the form of k s naught square r square. Now let's do the problem. So we need to find the radius vector defining the position of a point source. So let's say our point source is here. We need to find what is its position with respect to origin. If it is known that at the locations r1 and r2, so at locations r1 and r2 vector, the amplitudes are a1 and a2. So at these two locations, at r1 vector and r2 vector, amplitude of the wave is a1 and a2. We need to find where is the source. It's actually somewhere given that all three are in the straight line. Yeah, so all three are located on a straight line. So let's say our source is here, so at a distance t1 from this point and at a distance t2 from this point. Now you just need to imagine that wave is emanating from this source. So if the spherical wavefront reaches this point, so that radius of the spherical wavefront will be t1. So the power reaching at a distance t1 will be given by k into amplitude square, that is a1 square, into t1 square. So that's the whole power that's reaching for the whole spherical wavefront that's crossing the radius t1. So that same wavefront when reaches at a distance t2, so that time power crossing through will be k times a2 square into t2 square, a2 square into t2 square. Now there's no damping, so whatever power is reaching this spherical wavefront, same power is reaching this bigger spherical wavefront. So P1 is equal to P2, or Ka1 square T1 square is equal to Ka2 square T2 square, or T1 by T2 is equal to A2 by A1. So their amplitudes are in the ratio of their distances from the source. Sorry, not in the proportional, it's the inverse of that. So of course this distance is less, so amplitude will be higher. This distance is more, so amplitude will be less. And the relation comes to be A1 T1 is equal to A2 T2. Now we know from vectors that the position of this point, if this distance is T1 and this distance is T2, is given by T2 into R1 vector plus T1 into R2 vector divided by T1 plus T2. So from these two, so we'll just get rid of T1 and T1 by T2 and our answer will be this. Alright.